We're solving problem 10 from the 2020 F equals MA exam A. A block of mass M is attached to a massless string. The string is passed over a massless pulley at the end of the string is fixed in place. The horizontal part of the string is length L. Now a small mass is hung from the horizontal part of the string and the system comes to equilibrium. During this process, the block has been raised by approximately a height of, and we want to find that height. In this problem, from problem 9, we see that the tension on this block is mg. And for this other block, we can draw a series of lines where L is the distance between the starting point of the line and the pulley. Angle theta is angle of the line and it's pulled down compared to the perpendicular of length L, and all these tensions are just the tensions on the block. There's the tensions of the ropes here and the block pulling down on it. So from this, since theta can be split into 3 parts to make 180 degrees, we get that angle theta is equal to pi over 3. It is then that change in length is equal to L over sine theta minus L. We can then factor out an L here and plug in theta is pi thirds to get 2. Because sine of pi thirds is root 3 over 2. So take the reciprocal minus 1 and then factor out the L. Since we have conservation of string, we get that delta of the height change is change in length, which is, we can use calculators for this because in this exam calculators are allowed. So for this value, simply round to 0.15 L, and that is our answer for this problem.